So our project is comparing the popularity of electric cars and the amount of electric cars in different countries to their environment, to the health of their environment, and different policies that are aimed at environmental preservation. And so currently climate change is actually a very severe issue and can be felt across the globe. For example, in the ocean has warmed more than 0.6 degrees Fahrenheit since 1969. And this may not seem very substantial, but it's actually very significant when you think this is the entire ocean instead of like a bowl of soup. And this has led Antarctica to lose about 140 billion tons of ice between 1993 and 2019. Additionally, the acidity of surface ocean waters has increased by about 30%. And this is caused by carbon dioxide emitted from something like our cars into the atmosphere, which has dissolved into the water, increasing the acidity of the ocean water. And this has damaged a lot of the ocean life and continues to have very negative effects across the globe. A very popular way to combat this issue is by using renewable energy and specifically electric cars. And so on the graph on the right, the green bar represents the cumulative number of electric cars in the United States. As you can see, it's been growing significantly since 2011, which is the first bar in the graph. It has grown over 34 times from 2011 to 2017 and projected to grow another 102 times until 2021. We wondered if this growth followed a pattern that was able to be modeled by a regression. And so we tested 4 different regressions: linear, quadratic, cubic, and quartic. And the R-squared values are shown on the left. Since the quartic regression actually has the highest R-squared, around 99%, around 99% of the variation in the electric cars can be explained by this model. We also tried to leverage this high R-squared to predict some of the data that isn't readily available. And so, for example, in 2020, our prediction using the Quartic model was 2,158,500 electric cars, while the Sierra Club, which is where we got our data from, predicted 2,176,244 electric cars. As you can see, it's not super far off, which means our model matches the data very well. We also try to predict 2025 and 2030 as shown below. This makes sense because the normality plot in the number of electric cars is curved, as you can see on the right. And so a linear model is not very suitable, while a higher power model is more suitable. Additionally, we also tested the amount of EV usage or electric vehicle usage versus the EPI or the Environmental Performance Index. And this is basically a congregate of a bunch of data into one number that represents the different policies that a country has towards environmental protection and other similar factors. So we used a chi-squared goodness of fit test to test if they were correlated. Since it needs categorical data, we grouped the EV usage into 5 categories as shown below, and also the EPI usage in a similar fashion. Since both variables range from 0 to 100, we did not need to calculate specifically the expected EPI, and we could just use the EV usage as our expected values. On the right, you can see that since our p-value is around 0, which is less than the 0.5 that we initially said was our alpha, we have convincing evidence that our country's EPI is strongly correlated with their proportion of electric vehicle usage.
Growth of electric cars in the US. So we saw that the number of electric cars in the US is growing significantly, while charging stations have not grown as fast. So we wondered if the growth of electric cars was correlated with the growth of charging stations. So we got data from numerous states in the US on the number of electric vehicles sold recently and the amount of charging stations in that state. We came up with a model that quickly calculated. We came up with a model that could be used to quickly determine valuable information such as which states need changes in the number of charging stations, um, like if they needed more or less charging stations. And along with our model that predicted the um, number of electric vehicles in the future, we might be able to predict the number of charging stations in the future as well. So first we tried using a linear regression. So our least squares regression line was y equals 405.222 plus 0.075x, where x represents the amount of electric vehicles sold and y represents the number of charging stations. So correlation, we got r equals 0.997, which meant that we found a strong positive correlation between amount of electric cars sold and amount of charging stations. Our coefficient of determination, r squared, was equal to 0.995, which meant that 99.5% of the variance in the amount of charging stations can be explained by the linear model with the amount of electric cars sold. So on the right was our linear regression and our model. Before we could confirm that our linear model was appropriate, we looked at the residual plot. So our residual plot showed a clear curve and more residuals that were negative than positive. So even though the correlation and coefficient of determination were very close to 1, we could not use a linear model because of the problems seen in the residual plot. So because of those problems, we decided to remove 2 points of high leverage, which were states that had a significantly larger amount of electric vehicles than the other states. So then our quadratic regression model was y equals negative 0.0000237x squared plus 0.330x plus 6.349. Our coefficient of determination r squared was equal to 0.594. And even though it wasn't particularly high, we thought that the quadratic regression was an appropriate model since the residual plots did not show any curves or other signs of an appropriate model, as our previous linear regression did. Because some of our points of high leverage were removed, our model will not produce accurate results for states that sold large amount of electric cars. So our objectives for social good. We hope to have less waste from resources from better protections of future electric car growth. So for example, we want less materials to be wasted on gas cars and other products that will not be used as much in the future, so we could save energy and resources. We also want to use the significant growth of electric cars to provide hope to environmentalists and provide motivation for everyone so that we could help the environment together. I also want to encourage more EV usage with a correlation to a more healthy environment so that consumers are more inclined to purchase EV vehicles, knowing that it might have a positive impact on the climate rather than just being a marketing scheme.
Right. And here are some of the things that we can directly do to try to combat climate change. Number one is to urge policymakers to take action. And this way we can hold them accountable to pull out legislature that will positively impact the environment. Next, we'll use energy wisely, basically using efficiently all of the resources that we have, such as water and electricity. Use renewable energy sources, eat local and organic food, start a conversation to spread awareness about this problem, and take public transportation to reduce the number of cars on the road. And lastly, to take political action, which basically means basically vote towards laws that are more beneficial to environmental protection. here are some of the resources that we used to gather our data. Thank you so much for listening.